spelled everything correctly. Cool. Okay, so my name is Carson McKinstry. I'm one of the co-organizers here at Free Code Camp OKC. Before we get started, I want to give a shout out to Starspace 46 and Techlahoma for providing the space and basically being the reason we're here. Also want to give a shout out to Free Code Camp. They are pretty much the sole purpose or sole reason that we exist today. So today, hope you guys had a great holiday season. I sure did. So what we're going to do today is we're going to actually do a JavaScript refresher. It's been a couple weeks since you guys have possibly seen this, or at least it's been a couple weeks since we've actually formally talked about it. So thought it was a good time to do that. Okay, so we'll just go ahead and jump right in. So first thing we're going to talk about is we're going to go from really, really low level stuff, and we're going to get a little more advanced as we go on. Okay, so the first thing we're going to talk about is variables. So in general, well actually not in general, but there are three types of variables in JavaScript. There's the var, there's the let, and the const. Var is going to be something that's mutable, which means that it's allowed to change. Var is also scoped into its execution context. So what that means is that wherever it's declared, anything around it has access to it. A lot of times this is used for global variables and can store state in your application if that's what you're trying to do. With the advent of ES6, so ECMAScript 2015, we now have the let and the const keywords. So you might have seen these in other languages if you've dabbled in them. But let, like var, is mutable, with the exception that it is block level scoped. So now what that means is anytime you have any sort of brackets and you declare some variable with let inside of it, that's where it can be accessed, and it can't be accessed outside of it. And then if you start to nest it I'll show you in a minute. That's a little more complicated to talk about. And then the other one we have is const. Const is my preferred variable declaration. It is immutable, and it is block level scoped. So it acts a little bit like let, but if you try to change it at any point down the line, it will yell at you. You'll actually get a type error. There are a couple gotchas with const, but we won't get into what that does. That's for another talk. Next thing we're going to talk about is some data structures. So JavaScript has a bunch of data structures, but we're just going to talk about 5 of them, the most common ones that you'll encounter. So the first one are strings. This will contain any alphanumeric data that you might have, so names, places, anything like that. They can use either the single quotes or the double quotes. It really depends on your style, what you want to do, how you want to handle that. But JavaScript doesn't care either way, just so long as they match. Next thing we're going to talk about is numbers. Well, the next thing is numbers. So these will contain any sort of numerical data. So that'll be anything from integers to decimal numbers. You can't store fractions as of yet. I don't think that's ever going to be a thing. The third one is going to be Boolean. Boolean is going to store any sort of true or false values that you have for your application. These are often used for control. Set that backwards. Control flow, and are fairly powerful from what I have seen. Next, we're going to talk about these are going to be more, I would say, advanced data structures that you're going to encounter. So an array is the first one. So this is going to be a list of data. It functions like lists from a lot of other languages. It uses the square brackets in order to define it. And then individual elements are then separated by commas. In general, values inside of an array are accessed with bracket notation. So first thing, this is how you declare one. Whoops. So you got var myArray, you've got your square brackets, and then 5 pieces of data. I forgot to put this in here, but it is 0 indexed. So what zero indexing means is that the very first element is going to start at 0 rather than 1. So as you see here in this comment, we've got an example. So my array at 0 would be equal to 1. Next one is objects. Objects are pretty much the core of JavaScript, sort of. They are a key value store for pretty much any piece of data. You use curly brackets to define it. Then individual key and value pairs are going to use the colon to separate them. And then like arrays, any of those pairs are separated by commas. So those values can be accessed with dot notation, most notably with dot notation. You can also access them with bracket notation, but that's a little more involved in what you actually have to do with it. So here's an example of an object. So you've got my object is equal to something in brackets. So you've got my name and you've got my age. Now if I wanted to access my name, it would be my object.name, and that would equal to Carson. So we've got a little bit of a gotcha here. So in JavaScript, everything is an object, from your basic string all the way up to really, really complex objects. And with that, you actually have a property on every single thing called prototype. Most of the time you won't see it. But this is how we access methods that are attached to the object. So there are a bunch of built-in methods that you can use to manipulate data. This is a really non-exhaustive list. So for arrays, you've got things like length, which will return the length. You've got map, which will, at a high level, take everything in the array and apply some function to it and return a new array. Filter will remove any unwanted values that don't conform to some sort of function that you put in. Reduce, that one's a little more complicated. We won't get into it. On the right-hand side, we've got some string methods. So like array, we've got length. That allows you to, again, get the length of the string that's passed in. We've got split, which will take individual characters, or it'll take chunks of characters based on some sort of delimiter, be that a comma, a space, whatever. And that will split that out into an array. We've got slice. I spelled string wrong. But we've got slice, and that will take a piece of an array and return it. Substring does basically the same thing. Some caveats to that. And then replace does exactly what you think it would do. Takes any sort of, it takes a, I've lost the word. Basically, replace allows you to replace different pieces in your string with something else that you want. Next thing we're going to talk about is control flow. So this is where we're going to get into more of the meat of JavaScript and really any programming language. So JavaScript supports if, it supports else, and it supports else if. This allows you to create branching logic in your code. So at a very high level, what we've got here, can everybody read that? In the back? Cool. So basically what you have here, you've got your initial if statement. Whenever this sort of tree finds something truthy, finds something that evaluates to a true Boolean, it will execute the code within the brackets. So next thing you've got your else if. So an else if will say, if the first thing didn't work, check this second thing, and if that second thing is truthy, execute the code within my brackets. If all else fails and it doesn't find anything that's a truthy value, it will default to the else. Some more control flow. So we've got for loops. So there are a couple different types of loops in JavaScript. The most common one is going to be your for loop. Basically, this allows you to create a loop in your code that runs for a given number of iterations. So what we have here, we'll walk through this. Inside the parentheses, you've got a variable declaration. The next thing it does is it checks that variable against some given number or some constraint, and then it will iterate that variable. And then once you are inside the brackets, it does anything that's inside of there. And it does that for a number of times. We'll show you how to, basically what's going on here in a minute. Next thing is going to be your while loops. These are very similar to for loops, but they aren't as restrictive to being some sort of iterable number of times. So this could be literally anything that actually returns false. We'll stop the loop. So in this one, we've got while is truthy is true. It will do something, and then at some point down the line, because of some constraint, because of some potentially some if-else statement, if is truthy is set to false, it will break the loop. And we'll show you what this does here in a minute. Next thing we're going to talk about, and this is sort of the one of the biggest pieces of JavaScript, are going to be functions. So what functions are is they're very similar to what happens in math. They take some input and they return some output. Pretty simple. There's not much else outside of that. So what this allows you to do is it allows you to write code that can actually be reused other places by calling that function. So one of the big things with functions is they can be declared 3 different ways. So your first one, you've got just a regular function. So it's just function with your function name, any parameters or arguments you want for that, and then you do something with those parameters or arguments, or it just does something within the brackets. We won't get into this in depth, but what this particular style will do is it will actually hoist up to the very top of your code when it's run. So your JavaScript runs in 2 cycles, or the whole cycle runs through your code twice. First time it goes through, it reads it, checks for any errors, and then second time it actually executes code. While it's checking for errors, if it sees any of these kinds of function declarations, so function name, it will take them up to the top of the code, and it will run them when it needs to. So what this means is you can declare a function and then use it. Well, you can use a function before it's declared. And I'll show you what that looks like here in a minute. The second one is going to be when you are setting a function to a variable. This does pretty much the same thing as the first one does, except it doesn't hoist during that first phase. So if you declare something like this, if you declare var second function is equal to some function, and then you try to use it before you've declared it, it's going to say like, I don't know what that is. It's going to say, well, I am not allowed to use that yet. And then lastly, we've got actually what's called arrow notation. So this is used in ES6. If you have a browser that allows for it, you can use a function like this. So basically, you're declaring the function. You've got your parameters without the function keyword, and you've got an arrow, and that's an equal sign and the greater than symbol, and your brackets. And this basically does the same thing as that second one does. It doesn't hoist, it doesn't do anything interesting. There is one gotcha with arrow functions, which I won't get into right now. I did a talk on ES6 a couple weeks ago before the break. If you want to check that out, I will post a link to that in the Techlahoma Slack channel after this. Yeah. How do you mean? Yes, so it's only going to apply, and so because this is actually being used as a var, it's not going to be block level scoped, but it's going to be context level. And I'll show you that when we get to, when I've actually have some demonstrations of some of this. But yeah, that was a good question. If you declare this, so a good example, if you declare this inside of another function, or if you declare this inside of a block of code, it can't be accessed outside of it. Does that answer your question? Not quite. Let actually has, it's a subtle difference between var and let, and I'll get into that here in a minute. Most of this I talked about in that ES6 talk, so let and conts come from ES6. So if you want more in-depth, feel free to. Oh, the question was, so for this second one, is it block level scoped? Okay. Yeah. Yeah, so the question was, why would you use one style over the other? It really depends on what you're trying to do. My personal preference is actually use them as one of these second methods, just because I like the cleaner code. I like having to force those at the very top. But really, it comes down to preference at this point. There are some nuances to when you would use any of those, but for me, I don't think it particularly matters much. Okay. Next thing we're going to talk about, so this is we're going to get into some more, I don't want to say advanced topics, but more high-level things that you're actually going to need for some of the stuff happening in the next couple of weeks. First thing we're going to talk about are callbacks. So callbacks are functions that are passed into the arguments of another function, and then that function will call it at some point. So a good example of using a callback is actually going to be in some of the built-in array methods. So map, filter, reduce, for each, all of those take a callback. And what this allows you to do, what's particularly is happening with this 5-6 lines of code, is it's taking that array that I declared earlier, and it is applying some function to every single element in that array. And I'll give you an example of what's happening here in a minute. Next thing we're going to talk about, and this is probably the most esoteric, probably the most difficult thing about ES6, is promises. So promises are, so I'll read the MDN, so Mozilla Developer Network definition of what a promise is. So a promise is a proxy for a value not necessarily known when the promise is created. It allows you to associate handlers with an asynchronous actions, eventual success value, or failure reason. This lets asynchronous methods return values like synchronous methods. Instead of immediately returning the final value, the asynchronous method returns a promise to supply the value at some point in the future. So in essence, what that actually allows you to do is it allows you to execute some piece of code without knowing the initial input value. And then once it has that input value at some point down in the future, it will then use it. You can also have it reject, which will throw an error, and you can catch that. So in general, you don't necessarily need to know how these are created. A lot of libraries will actually handle that for you for specific cases. But I do challenge anyone in the room, if you want to find out exactly what you're doing, go check out how promises actually work, check out how to create one yourself, and then potentially do a talk on it. That would be awesome. So we've got syntax for promises. So the first thing we've got up here is we've got some function that returns a promise. So this function is executed. It waits for some response, and it waits for some value to come back, and then you use it. So the first thing you do is you've got .then, and what this does is it gives you a response, and you can do something with that returned value or that returned response. Next one is a catch, so .catch. So you can only have one catch in a promise chain. What that allows you to do, if there are any errors or if the promise is ever rejected, it will return an error. And then you can use that error, you can handle errors like that. So let's use both callbacks and promises. So we're going to talk about asynchronous JavaScript and XML, commonly referred to as AJAX. So this is actually how we talk to outside APIs, how we make calls to other websites or other other services. So there's two common patterns that actually will use callbacks, or they'll use promises. Typically speaking, most people will use a JavaScript library in order to do those requests, because the vanilla ones are kind of painful. It's probably 5 to 10 lines as opposed to 2. jQuery and Axios are two really common libraries that actually will perform AJAX requests for the front end. There's a couple on the back end, so for the node environment that you can use. And we'll show you what both of those look like here in a second. So the first one, so this is library agnostic. So here on the left, we have some get function. So what a get function does is it goes to some API or some other website, and it says, I want this particular piece of data that you're storing at this particular endpoint, or this resource that you're storing at this endpoint, and then it returns it. So for the callbacks, so we've got two callbacks here. We've got one that will handle any data that comes through, and then the second one that will handle any errors that come through. That may be a little difficult to read. Do you guys see where those two functions are separated? They're separated by commas. So this first one, whoops. So those are separated by commas. So the function, it takes an argument data, which will be what's being returned from your GET request. And then you can do something with that data. The second one is going to be your error handling function. So if there's any errors that come back from this API or whatever you're using to get the data, you can handle it there. Second one is going to be how we handle it with promises. So this is a really, really nice way to use promises, a really good thing to use promises for. So you make some requests. So you've got get/some endpoint. That then returns some value, and then you can use it with the .then method. So this does also take a callback, technically speaking, but it's not directly in the function. It's actually what's being used by the promise. And then, like I said, we've also got that catch statement, which will catch any errors that happen during that entire chain. So one thing to remember about promises, and this is more of a advanced usage of promises, is that you can chain then statements. So say you get some data back from your API and you want to transform it somehow, but it's not in the right format you want. If you return that value, you can use it in another then statement, and then on down the chain. But I wouldn't get too caught up in what that's actually doing. So we've got some resources for you. So these are just some general resources. So you've got freecodecamp.org, very obviously. They've got an excellent JavaScript section. Then there's the Mozilla Developer Network. So this is going to be, this is developed by Mozilla, so the people that created Firefox. And it has a bunch of stuff that actually has to do with the web. So everything from HTML to CSS to JavaScript, WebKit, WebGL, anything like that. Anything you really want to know about the internet and how some of that works, the Mozilla Developer Network has it. Their documentation is can be a little bit more challenging for new people. So if you're a little intimidated by that, W3 Schools does a really good job of, I don't want to say dumbing it down, but making it at a much lower level so you don't have to deal with all the technical jargon that you might get from MDN. Okay, so that's really the end of my slides. So I've got, okay, so I've got can everybody read that? Nope. Can you read it now? Better? What if I change the theme? Do what? Okay. How's that? Better? People in the back? Cool. Okay, so a couple weeks ago, we actually did, go back to the index, we actually did a talk on Node. So the environment that I'm using right now is actually VS Code, but down in my terminal, I'm using what is known as Node. Whoops. Node allows you to run JavaScript outside of your browser without much of an issue. So we'll ignore the top two things for now. So we'll slowly walk through this. So let's first talk about variables. So there are three variable types. So you've got var, you've got let, and you've got const. So like I said, var is typically global, and it is also context scoped. So what that means, I'm going to write a function real quick. Print name. And so inside of this, we're going to say var name equals Carson. What this will do is it will console.log my name. So that's kind of interesting. I mean, that doesn't do much. We'll go ahead and show you what that does. Print name. Pardon? There you go. So it printed my name. Now, if we go inside of here and say if true, whoops, we're going to change the name to Daniel. It will go ahead and change that name. Name gets changed to Daniel. So let's see what happens if I change that to let. Actually, let's do this. So you would assume that it's going to do the same thing. So whenever you redeclare a var in JavaScript, and if it's already been declared, it doesn't do anything with it. It just says, oh, hey, I already know what that variable looks like. You go ahead and reassign it. It should go ahead and print out Daniel. Let's go ahead and try let real quick. So what let lets you do is it actually forces it to be block level scoped. So when I say block level scoped, anything within these brackets is going to be that block. So if you notice, we've got another block inside of this if statement. Can anybody guess what's going to happen to the name? What's actually going to be printed? Yeah. Oh, sorry. Oh, and I guess it's acting up again. This was working yesterday. Basically what's supposed to happen is if let is declared in another context, the let that's in that context shouldn't change, or the variable outside of that context shouldn't change. Now let's go ahead and see what happens with const. Anybody guess what's going to happen with const? Oh, I keep not saving. Thank you. Let's try that again. The demo gods, I swear. Yeah. So it did exactly what I said it was going to do. So that name inside of that if statement is completely different from the name outside of it, and it doesn't care. So if we were to then console log this, it would actually come out with Daniel and then Carson. So let's try this with const. Anybody guess what's going to happen? Yeah. So let's try redefining it. Anybody guess what's going to happen then? Yep. So what this error actually is saying is that you're trying to assign to a constant variable. So my preferred method whenever I'm working, and const and let are at like 85% coverage on most browsers, so it's pretty safe to use them. I like to use const, specifically for this sort of catching, so I don't accidentally mutate some variable that I need somewhere else. Okay, so go ahead and comment out this, so I'm not reusing it. Next thing we're going to talk about is we're going to talk about the data structures. So from here on out, I'm going to go ahead and use const just as my own personal tick. So we've got our strings, and those are declared with double quotes. And if I change this to single quotes, it doesn't care. Next one is going to be numbers. So I've given the famous 42 as my number. We've got our booleans, which are going to be true. This could also be false. We've got an array. So an array can hold pretty much any data that you want. This could also be my name. Doesn't care. There are some languages out there that say, ooh, it needs to be the exact same data type no matter what inside this array. JavaScript is pretty nice about that. It doesn't care. Next one is going to be an object. So this is what you'll work a lot with. So this is what's known as JavaScript object notation. So you've got your curly braces. You've got a key, which in this case is going to be name, and you've got a value. In this case, it's going to be Carson. And you've also got age, which is also a number. Like arrays, any value can go, any sort of data structure can go into the value of a key in an object. So today's date is going to be new date. What new date actually does, I won't get into this, is actually gives you the current date. And so I'll show you what each of these looks like when you print them out. I'll log my string, my number, my boolean, my array, and lastly, my object. So you've got your string, you've got your number, you've got a boolean, you've got your object, and like I said, new date will go ahead and put out the current date. And what's known as ISO 86, you don't need to know that at the moment. And then you've got an array. So let's go ahead and talk about some gotchas with JavaScript. So like I said, every single thing in JavaScript is an object, which means that it has different properties and different methods that are attached to them. So a very common one that you'll see is going to be length. So you can use this to check the length of a string, to check the length of an array. So let me show you what this does. So let me go uncomment my string and my number real quick, or my array, pardon me. And so what length should do is it will return, and this will actually print out the length of those things, the length of those values. Node. So like I said, so the string was 9 characters long, and it returned 9. The array was 5 characters long, and it returned 5. So comment that out. So the next thing we're going to talk about is control flow. The first thing we're going to talk about are for loops. So we'll walk through this real quick, and I'll actually rewrite this. So the first thing you do is you've got for, and you've got you've got parentheses. And inside the parentheses, you need 3 things. You need an initial case, you need some sort of test case, and you need some sort of iterator. In this case, so we've got var I is equal to 0. We're going to say I is going to be less than, let's just do 10 for time's sake. And then we're going to iterate it. So what this symbol means, so this plus plus, is the equivalent of I is equal to I plus 1, I is equal to I plus equals 1, and then just I plus plus. What that does is it just goes ahead and adds something to that variable. So open our curly brackets, and then we're going to just go ahead and for now, we're going to log out the iterator, so that I. And I'll show you what that looks like. If I save. And it printed out 0 to 9. Can anybody tell me why it didn't print out 10? And why? Right. And I also started at 0. Oops. So the next one we're going to talk about are for loops. I can comment things out. Next thing we're going to do is talk about while loops. So, while loops, like I said, will only execute when the thing inside of the parentheses is truthy. And what I mean by truthy and what I mean by falsy are that certain values and certain things in JavaScript will evaluate to one of those two things. In general, I would say go ahead and research that on your own, because that can be a little bit more involved in figuring out what those actually mean. And I think it's a good exercise to figure out what each thing in JavaScript evaluates to. But we're going to be really simple here. We're going to just use a regular Boolean. So var something truthy. While that is true, it's going to console log I should only print once. And then what it does then is it go ahead and sets something truthy to false, and then it will break the loop. So this should only print out once if I save it. Yeah, so it only printed once. So we're going to go ahead and mock a for loop, actually. So we've got var count is equal to 0. And let's say count is less than 10. And we're going to console.log, and we're going to do console log the count. And what this will do is we're going to go ahead and iterate it again. So this looks different from the normal for loop, but it's going to do the exact same thing as what we did earlier. Let's go ahead and run it, and it prints 0 to 9. Pretty simple. So, next thing we're going to talk about are going to be the if, the else, and the else if. So the first one we've got is going to be the if. So obviously 1 is going to not greater than 2, so it's not going to print this out. But let me go ahead and change that so that it will be truthy. So what this does is it goes through the tree and it finds the very first thing that says true, and it will execute it. So that should only reach to the first constraint truthy. So let's change that back to falsy, and we're going to change the second one to truthy. So this one should only be reached if that first one is false. Obviously 1 greater than 2 is not true. And then the second one is also truthy. So 1 less than 3 is obviously true. Let's go ahead and run that. So the second one got printed. So now if all else fails, we have an else statement. And this will go ahead and print out if all else fails. Okay. So I've gone over quite a bit at this point. Does anybody have any questions? So let me actually give you a great example of that. So, the question was, why would you use for over while, or why would you use either one of them? Again, it comes down to style. There are some places where you can actually you can optimize using while loops over for loops, or the vice versa. But in general, it doesn't really matter. In most cases, it's not going to matter. You'll get down the line and you'll actually learn some better ways to handle some of that. I think the last time I wrote a for loop was, I can't remember the last time I wrote a for loop or a while loop outside of this. I actually use map, and I'll actually get to that here in a minute. So here's an example. So we're going to use this myArray. Oftentimes we use a for loop because it's going to make more sense when you're trying to read it. A good rule of thumb is to always write as if the next person that reads your code knows where you live. And often that person that's going to read your code is going to be yourself. So you always want to write something that makes it easier for you to read. So here's a good example. So let's say O for I is equal to 0. Let's make sure when I is less than, I'm going to do myArray.length, and then I++. And then we'll go ahead and console log myArray at I. So can anybody guess what that's going to do? Pardon? Yeah. So we'll go ahead and run it. And so you see my name, 2, 3, 4, 5, basically everything that was in that array. And then the if else, because I didn't comment out something else. So the reason I would use this over a while loop is because a while loop is going to look a little more like this. So you've got var count is equal to 0, while count is less than myArray.length. You need to console log myArray at I, or at count, and then you need to iterate that. So there's a lot more stuff in that particular, those 5 lines of code that can mess up. You might forget to iterate it, and then you're going to have a really, it's going to keep printing out the first thing in the list over and over and over again. It might crash your browser. And you don't want that to happen. Typically, the for loop is going to be a lot cleaner. Well, let's find out. So let's say, Daniel, give me a good way to delete something out of an array. Yeah. Okay, thank you. So let's do myArray.pop. So what .pop does is it actually will take the very last item in the array and pull it off. I typically don't use pop because it's completely against the paradigm I use, but we'll use it for now. So can anybody guess what's going to happen with this? Right. And in fact, it's going to error out on the last one. Well, when I say error out, it's going to return undefined. So let me make this a little easier to read. Go ahead. Right. So this is one of those gotchas. So, you're right. So JavaScript has a lot of weird quirks. This is one of them. Is that if it doesn't know what it is, it's going to return undefined a lot of times. Yes. And I'll show you what this actually will do. No, that's going to be a little more in depth than what we really need to. So the question there was, what happens when you start removing items from the array as you're looping through it? And what happens is the length of the array goes down. You also are going to lose that item. You're going to lose that item from the array. So let's go ahead and scroll down. I'm going to delete this. Next, we're going to talk about functions. So these are the 3 ways to create functions, like I said. So we've got add. So we'll do, let's say, add 1 + 2. We'll go ahead and log that real quick. And that should go ahead and log out 3, and it did. So can anybody guess what's going to happen if I do this? If I call it before I've declared it? No. So it's actually not going to error out. Right. So it's still going to work. So when I say you sort of have this, it's called a REPL. It's the read, eval, print loop. So first thing it does is it reads the entire file, it evaluates the file, and then it prints it. Prints anything that happens. And then it loops through that again if it needs to. And when you declare a function like this first one, this gets hoisted up to the very top of the file, and it will have access to it no matter where it is in your code. Or it'll get lifted up to the highest level in the block or the context. So we'll go ahead and comment that out. So subtract does pretty much the same thing, but we're going to do, let's do 3 minus 1. And that should return 2 if I log it. So it logs 2. Now to show what happens when you try to use something that's not, a function that's not, like I said, hoisted, see what happens there. Ooh, it doesn't know what it's trying to do. So right here, despite the fact that we can very clearly see that subtract is a function, subtract is not a function to the REPL, to node, because that didn't get taken and put above the console.log. So this is one of those gotchas in JavaScript that will screw you up for a long time until you sort of figure it out. So if you're declaring, so the general rule of thumb is if you're declaring a function with just the function keyword, it can go anywhere in your code, anywhere within that block of code. If you are trying to declare it like this, so var subtract equals function, so on and so forth, you have to make sure that that is declared before you use it. And then, yeah, so you can actually use let, you can use cont, you can use pretty much anything, or any of the variable names there. And that carries with it the same baggage that a normal, a primitive, is what we call strings and all those. It carries that same baggage. Yep. So I'll change that back. And then lastly, we've got this multiply function, which is going to use the arrow. So what this arrow function is it's a part of ES6. It's not used, it can't be used in every single browser just yet. It's a more futuristic thing that you can use with JavaScript. But what it does is it basically does the exact same thing as this function right here. Yeah, I guess you can't really see the, well, just trust me on that one. So we've got our variable declaration, we've got the brackets or the parentheses with any of the parameters that we want. We've got our arrow, and then we've got our block of code that's run. So what this should do, let's go ahead and run multiply two times 4. It should return 8. And it did. So the same thing applies as for the previous example. It's going to error out because it doesn't know what the multiply function is. Okay. I will show you. So arrow functions come with some really interesting features. And I'll show you in the, let's show with an array. So const my array, equal to 1, 2, 3, 4, 5. We're going to use something called map. So what map does on an array is it will loop through the array and apply whatever function you supply to it to every single item in that array. So let's set my new array is equal to my array dot map. And so this will get into what we how we use callbacks, and we'll go over more in depth what happens here in a second. So normally, what you would have to do is write this with a function as your as the callback to map. My new array. And what I'll do is I'll go ahead and square every single number in that array. So obviously we've got my array, which is 1 through 5. This should print out each of those squared. Apparently I already my other array. This is what happens when you don't comment out your code. Okay. So it printed out 1, 4, 9, 16, 25. So it doubled everything that is in the original array. Does that make sense? Okay. So the question was, why do we use arrow functions? So one of the ways that we can use them is make our code a little cleaner. So that looks a little easier. And actually my linter went ahead and removed any parentheses. So you don't actually have to have those parentheses when you're doing that. And it should work just the same. And this is the part that trips up a lot of people. Can anybody guess what that does? If not, okay. So what this does is it actually, arrow functions allow you to use what's known as implicit returning. So anything after that n or after that arrow is going to be returned from the function. So this should, in essence, do the exact same thing as what everything else was doing. 1 through 25. So that's one of the reasons why a lot of times you'll see this fat arrow notation is because it's easier to read. Doesn't carry this, if you don't need access to this keyword, well, I won't get into why that's a problem. This is typically a better way to do it because it's easier to read. It's more, it's what we call declarative. You see exactly what it's trying to do rather than having all this additional boilerplate code. Okay, so with that, so map, like I said, takes a callback. Now let's see what callbacks do in the real world. So we've got I actually set up a really simple server that's got a single endpoint on my computer, and I'm going to hit it, and I'm going to return some sort of data from that. To do this, I'm using a library in Node called request that takes in the first parameter for any request is the endpoint that you're trying to hit. So in this case, it's going to be localhost /some/endpoint. And then it takes a callback, which takes three parameters. You've got an error, you've got the response, and you've got the body. So if any errors come through, you can handle that error. If a response comes through, that will contain all the metadata about what you're doing, about what you're trying to do. That'll include the domain that you came from, the domain that you hit, and a bunch more information than you typically need to when you're first starting out. And then you also have a body. So the body is what is coming back from the server. That's all the data that you are wanting back from the server. So I'll go ahead and run this real quick, and we'll see what that does. So our body was success. It returns a piece of JSON or an object that has two keys. It has a success key and it has a message key. Success says true. Message is some JSON response. So lots of different APIs will return different information from them, and some of them will return them in different formats. Bryce Jeck is actually going to be talking about going more in depth on what an API is next week, so I won't get too into that. So that's the first sort of pattern for making AJAX calls. Oh, and this is what an AJAX call is like, by the way. So the second way is to use something like Axios. So Axios is my go-to promise-based AJAX library. What this does is it has a couple methods attached to Axios. Let's say the first one is get. There are three others that you will typically see, so post, put, and delete. For now, we're going to go ahead and deal with the get request. So a get request will do basically the same thing as what the first request did. So it goes out to some API endpoint, it brings back data, and it uses it. So the first thing we have after that get is we have a then response. So the then response will say, okay, so I found data that came back, we've got the response. Now I want to be able to use that response. Typically when you're using something like Axios, the response will contain a data property which will contain what is coming back from the server. which is why we're having to do response.data. Oh, and I'll show you what that does as well. It does pretty much the same thing. So the other thing is we've got a catch. So the catch will actually handle any errors that come through. So if I say, let's go ahead and turn off my server real quick. And in fact, this is actually not, this may not work. But if I try to make that same request again, it's not going to happen. And it's like, I don't know what I'm supposed to do with this. So this is what a response will look like. In fact, this is what the error is going to look like. So, and you just have to handle anything that comes through with that error. Okay, so like I said earlier, we have, you're allowed to chain thens. So what do I mean by that? So let's say I want to get that success message off of there. So success is equal to response.data.success. If it's false, I just want to console.log success was false. If not, I want to return that success. So what that lets me do is that then says I'm allowed to use it here in a second then. So and I'll show you this with the error notation. So response. So our response should contain that success. Let's see if it does. Thank you for catching that. Let's do if not success. So what that little exclamation point does is it will return the opposite Boolean value of whatever you're doing. Oops, pardon me. Our response. So you've got that from above and it's true. So it went through that first then, it did whatever it wanted inside of there, it performed some action, and then it went through and it passed it on to the next then down the chain. Now, to show what the catch does, so let's say if there's a success, we're going to return, in this case we're actually going to throw, don't worry about what throw means, new error, example error. So what that'll do is that catch will then say, oh, hey, I found an error. I need to stop. So you've got your error, and it says error, example error. That's going to get passed down through that chain. So I know promises and callbacks and AJAX are typically going to be a lot more difficult. So does anybody have any quick questions about them? Okay. Does anybody have questions about the rest of the, any of the information I've given today?